My name is Lindsay Marshall and I'm the curator at Maropeng. That is possibly one of the biggest misconceptions around, and it's often what puts people off finding out and learning more about this topic. In order to understand it, we need to take a step back and look at a person by the name of Carl Linnaeus. He was a Swedish botanist in the 1700s, and he was the first person who classified all living species into various categories, starting very broad into a particular kingdom, working all the way down into species. For example, let's look at our scientific name. We are of the genus Homo and the species Sapiens. Now, modern great apes, by that I mean your gorilla and chimps, for example, we with them formed part of the superfamily called Hominoidea. So Carl Linnaeus in the 1700s had already made this sort of relationship because of the morphological similarities. Now, what the paleoanthropological and fossil record have shown is that in fact we shared a common ancestor. So if you imagine a family tree, we've got the great apes on one side, we've got humans on the other, modern humans on the other, sharing a degree of similar traits. Remember, between chimpanzees and modern humans, there's a 97% similarity with the human genome. So in a modern context, you've got these two, call them branches of a tree. At the base, at the beginning of this tree, dating back between 7 and 8 million years ago, there was a common ancestor. So the link is that we shared a common ancestor and then the trees diverged, rather than the link being made within a modern context. And that's what often gets people confused. You know, as Homo sapiens, there are no other species of the genus Homo anymore. It's just us. So on that basis, we then look to the primates and would deem them as our closest living relatives, even though the distinction is reams apart. You know, but in terms of if we would say who's our closest living relative, we would look at the modern apes, and that we shared a common ancestor with them. Well, I think to understand that, we need to approach it from a slightly different angle. I've talked about Carl Linnaeus, and then of course there was Charles Darwin, who really highlighted the theory of evolution by natural selection. So we've got Carl Linnaeus on one hand, who says we can group modern humans and primates together. Charles Darwin, who looks at the morphological similarities between chimps and modern humans, and he says from there he first proposed this common ancestor. So all these theories were abounding, but there was no tangible fossil evidence to show this. So we're at a situation where we've got these theories abounding where the proposal is there was a common ancestor. We now need to see where's that so-called missing link. Where did that change start to happen? So the focus at that time was, of course, Europe, because that was where it was at the time. Africa, what was there going to be in Africa? It was an empty continent. But as Charles Darwin had in fact said, where do you find modern primates? In Africa. Carl Linnaeus would have had probably similar thoughts as well, given the grouping that had happened. So it was realized that perhaps Africa needed to be a focus, but the socio-political context that the scientific work was going on at the time kept it pretty much to the side. And then in 1925, there was a major discovery by a man called Raymond Dart at a site here in Taung, which is now part of the Cradle of Human World Heritage Site. And this was the discovery of the Taung child. Now, what made the Taung child was some very specific features. First of all, from the endocast, and this is when you have a fossilization taking place of soft material, of the cast being made of what the soft material would have looked like. The gyri and sulci, the elevations and grooves within the brain, were a lot denser than what would have been an ape, for example. So that already got Raymond Dart thinking. Second feature, the face did not stick out as much. It was not as prognathic as that of an ape. There's another point there. Third thing, The teeth, the canines, if you look at an ape, a chimpanzee or gorilla, for example, the canines stick out. They're very, very visible and you're very aware of them. These were much smaller. And then the other key feature was that the foramen magnum, now this is the hole in the base of the skull where your spinal column enters, was relatively far forward on the skull. Now this would have said to you that this creature was bipedal. It walked upright. Now these are very distinct human-like features that you do not find in an ape. So immediately Raymond Dart realized that this was something special, and this was in fact the holotype, meaning the first discovery of a specific species which he designated Australopithecus africanus. So you're already starting to see distinguishing features. If we then have to compare humans back to, say, Australopithecus, which is perhaps one of the key finds in the cradle of humankind. For starters, the brain is much bigger, perhaps 3 times the size of an Australopithecus, even though the Australopithecine's brain would have been bigger and more advanced than that of an ape, for example. We are much bigger. Your average size of an Australopithecus, approximately 1.3 meters, whereas we are, we range in size. There was a lot of sexual dimorphism in our early hominid ancestors, meaning between male and female there were very distinct differences. We don't see that now, for example. The other thing is the arms of your Australopithecines would have been much more adaptable and easier to climb. While the Australopithecines were predominantly bipedal, the environment would have dictated they would have spent a degree of time in trees as well. So these are the features that we start to look at. And of course, what's the big difference? You and I wear clothes. Your Australopithecines, the early ancestors, would not have. Perhaps their skin and their hair, pretty much what we'd see on an ape as well. We have found a wide range of evidence. Sterkfontein Caves, a site, is a major site, for example. The tools technology dates back to 2.6 million years ago. The first, it's so named after a site, an older one in East Africa. So the earlier Stone Age is made up of 2 distinct industries, the Oldowan industry and the Acheulean industry. Oldowan tools, we find a lot of at Sterkfontein, dating back to approximately 1.7 odd million years ago, which is quite interesting. So for approximately 1 million years, there was an unchanged tool industry. So the adaptation that had taken place was very successful and widely used. And across the board, from South Africa to East Africa, you see a lot of similarities. Then you move into the Acheulean. And we actually have a site right here at Maropeng where we have found Acheulean stone tools. So your older tools, relatively crude, quite big, quite chunky. What would happen is a core, a raw piece of rock would be taken, and from it flakes would be struck, used for chopping and cutting, hitting down trees, opening up bones, that kind of thing. Your Acheulean industry, starting to get slightly more advanced. We see this at approximately 1.5 million years, all the way up to 600,000 years ago when we see evidence of the Acheulean in Europe. What does that tell us? Movement from Africa through into the rest of the world. So throughout many sites we see evidence of this early tool use. At a site called Swartkrans, which is opposite Sterkfontein Caves, we see something very interesting. We at a time roughly around 1 million years ago, where, as I've mentioned already, we are the only species of the genus Homo remaining. So there's no other even comparative cousins, so to speak. However, 1 million years ago, we find evidence of 2 species coexisting. We've got Paranthropus robustus and Homo ergaster, coexisting, living at Swartkrans. Paranthropus robustus, very confined to the environment that they could live in. They were very specified. They could only survive in a certain environment. Homo ergaster, same genus as ourselves, bigger brain, more advanced, starting to make tools as well. They could outcompete. They could adapt more. What is interesting, and it's quite a lot of controversy in the scientific circles now, is they're saying that Paranthropus robustus while perhaps the more uncivilized, so to speak, cousin, they eventually died out. They were making tools, but bone tools. They were modifying horn and bone material to make tools, often to dig out termites, and this has been shown in experimental work. So you've got a bone tool technology, you've got a stone tool technology. So over this time, we're starting to see major developments happening. Well, the first thing you have is your fossil and your archaeological evidence, which dates, which has the oldest evidence around the world. Before we even get to modern humans, if we look at the Tang child, Mrs. Pless, we're dating between over 2 to over 3 million years ago. Modern humans, the Homo sapiens sapiens, we see at approximately 200,000 years ago in the fossil record. This is corroborated by the genetic work that's been done when we look at mitochondrial Eve, for example, mitochondrial DNA, where they can also pinpoint modern humans to Africa at approximately 200,000 years. Another interesting point is there's a site in the Cape called Pinnacle Point, where dating back to 76,000 years ago, and even possibly as far as 164,000 years ago, there is evidence that the human population at that time, at that site is where they found the evidence for this, they were heating, we talked about stone tools just now, they were heating the stone tool, the rock, the raw material, because they realized that by heating it, it made it easier to strike flakes off it. So here we have the first evidence of modern behavior. It's engineering, in fact. So all of these dates, whether it be genetic, fossils, the archaeological record, things like the heating of rocks to make stone tools, all take us back to Africa. I describe it the way I was taught history when I was I think it was in primary school. It really is by understanding the past, we can understand who we are now and where we are going. It's not about facts, it's very intangible stuff. It's about saying, let's not take for granted the journey we have gone through. Let's not take for granted the earth that has sustained us along this route, the cameras, the equipment that we use, the fact that we can trace the beginnings of this technology to 2.5 million years ago, that we can trace when we first started walking upright, how our brains have developed. It's a form of appreciation. We're all inquisitive, we all want to know, and by doing so, it can look us forward into the future.